this. All right. So 2.1, we talked about classifying matter. As you did the reading guide, we talked about two ways or two categories that we could classify matter. But I want you to think about each piece of clothing that has a label and it recommends cleaning methods. A 100% cotton shirt may need to be ironed after washing. A cotton polyester blend fabric may come out of the dryer wrinkle-free. There is no cleaning process that works for all materials. So why are elements and compounds classified as pure substances? Well, a pure substance is a matter that always has exactly the same composition. Table salt and table sugar are two examples of pure substances. Substances can be classified into two categories, elements and compounds. Every sample of every given substance has the same properties because the substance has a fixed uniform composition. Salt is sodium chloride, and every grain of salt is sodium chloride. So that's why it's referred to as a pure substance. Water, H2O, hydrogen, 2 hydrogen per 1 oxygen, no matter how big the size of the water, whether it's one molecule or a cup of water. So how do mixtures differ from pure substances? Well, an element is a substance that can't be broken down into simpler substances. And an element has a fixed composition because it contains only one type of atom. So when we talk about substances, right, a compound can have combinations, but sometimes they don't have a combination at all. Helium in a helium balloon is just helium. So we can't break that into other parts. Where water can be broken down into the hydrogen and oxygen. Sometimes elements, well, not sometimes, all the time, elements break down to atoms. So some elements are solid at room temperature. Most soft drink cans are made from aluminum. Carbon is the main element that makes marks with a pencil. We call it graphite, but graphite is just a label for the way in which the carbon is laid out. But it's really just carbon. If you use a regular pencil, you're just using carbon. Carbon is like charcoal. That's carbon too. So when you burn things, it takes organic material and oxidizes it. In other words, it removes the oxygen, burns off some of the hydrogen, and what you're left with is mostly carbon. That's why you can take a stick, light it in a fire, and then write with the charcoal. Okay. The element oxygen and nitrogen are the main gases in the air you breathe. Most of the air that we breathe, regular atmospheric air, the majority of it is nitrogen. The second highest concentration, I believe, is oxygen, and our lungs just take the oxygen out. Nitrogen is what we call an inert gas. It doesn't interact with anything. Okay? Wait, is nitrogen inert? I think so. Yeah. I gotta think about it. Anyways, no, it's not. No, it's not. It's not inert. But we don't breathe it in. Okay? Symbols for elements. Chemists use symbols of 1 or 2 letters to represent the elements. The first letter is always capitalized, and if there is a second letter, it is not capitalized. Carbon is capital C. So if you look at the periodic table that Mr. Adams has hanging up on the wall, or hanging up from the ceiling over there, and you look for the capital C, it's kind of hard to see, but there it is. That represents carbon. Al is aluminum, and Au is gold. Now, some of these have Latin names, and so gold, you might think, well, why isn't gold Go? Well, in science, we like to use Latin words, and so the Au represents the Latin name for gold. Okay, it's the first 2 letters for the Latin name for gold. Symbols allow scientists who speak different languages to communicate without confusion. For example, nitrogen is azote in France, and I'm sure I'm mispronouncing it. It's stick-off in Germany, nitrogeno in Mexico, but all scientists use the N as the symbol for the element nitrogen. Okay? And I misspoke. Nitrogen does not interact with things, but it's not noble. That's I was thinking of two different things. Okay. All right. Keep going. Aluminum, carbon, and gold are elements that you can see in common objects such as cans, pencils, rings. Mixtures containing iodine are used to prevent and treat infections. So when Mr. Adams had surgery on his hand last week or whatever, my hand was colored kind of almost like a orangish brown color. That's because they put iodine on my hand because it kills off any infection. It reduces the chances of me getting infected when they cut me open. Okay. How do mixtures differ from pure substances? So we talked about atoms and compounds. Well, let me back up. Elements have atoms. Compounds have molecules. Okay. Elements have atoms. Compounds have molecules. Now we're going to talk about mixtures. A compound is a substance that's made from two or more simpler substances, can be broken down into the simpler substances. A compound allows two or more elements to be joined in a fixed proportion. Now what that means is when I take any amount of water, it's going to be 2 hydrogen to 1 oxygen atom. So we'll have 2 hydrogen atoms connected to 1 oxygen. And so the properties of a compound differ from those of the substances from which they are made. So water is composed of elements of hydrogen and oxygen. Oxygen and hydrogen are gases at room temperature, but water is a liquid at room temperature. Hydrogen can be fuel for a fire. Oxygen can keep a fire burning, but water does not burn or help other substances to burn. And that's fascinating when you think about that. If I take hydrogen and light a match to it, it will explode. If I have a campfire and I blow a bunch of oxygen into it, it will increase the fire. But if I have a campfire and I pour water on it, it puts the fire out. All right, silicon, not to be confused with silicone. It's really hard for me not to say silicone when I say silicon. I have a video on YouTube where I explain photovoltaic reactions, and I kept saying silicone. Anyway, silicon dioxide is a compound found in most light-colored grains of sand and in crystals of quartz. It is colorless, transparent solid, yet silicon dioxide is made from a colorless gas, oxygen, and a gray solid, silicon. In silicon dioxide, there are always 2 oxygen atoms to each silicon atom. So they're saying, hey, this is what silicon looks like. This is what oxygen looks like in a tank, right? Because it's a gas. You can't just put a picture of oxygen, so they put a tank. That's funny. But when you combine them in this fixed proportion, it looks like this. Okay? So how do mixtures differ from pure substances? Well, if you make a salsa, a recipe can guide you. You can use exactly the same amounts in the recipe, or you can adjust the ingredients to your taste. Salsa is a mixture. Each batch is slightly different. So the properties of a mixture can vary because the composition of the mixture is not fixed. You want to add a little more salt to your salsa mix, you can. If you want to put a little extra peppers because you like things a little spicy, you can. So mixtures can retain some of the properties of their individual substances. In other words, if I take salsa, it tastes like tomatoes, it tastes like onions, it tastes like peppers, but if I add more salt, it tastes saltier, right? So it maintains some of its properties. The properties of the mixture are less constant than the properties of a substance. So when we talk about substances, we're talking about molecules and atoms, fixed proportions. When we talk about mixtures, there's some variation. Also, mixtures can be classified by how well the parts of the mixtures are distributed throughout the mixture. Heterogeneous mixtures what that means is in a heterogeneous mixture, the parts of the mixture are noticeably different from one another. A lot of this has to do with the distribution of the parts of the mixture. Sand and water. Sand is not going to mix into water no matter what. Okay? That would be a type of heterogeneous mixture. Now, homogeneous mixtures, in a homogeneous mixture, the substances are evenly distributed. That it is difficult to distinguish one substance in the mixture from the other. So if I take water and I pour salt in it, the salt actually breaks down into the salt molecules, the sodium chloride, and they place themselves in between the water molecules. So the salt dissolves. That's a homogeneous mixture. You can't, and when it's done, it kind of looks like just water, right? Sand is a heterogeneous mixture with different kinds of grains. So sand itself is like rocks ground up and different crystals ground. It's a bunch of stuff ground up. A spoon is stainless steel, and that's a homogeneous mixture of iron, chromium, and nickel. So stainless steel is mostly iron, but it's an alloy. It has extra stuff in there to keep it from corroding. Mixtures. Do the contents of 2 cans of mixed nuts meet FDA regulations? According to the FDA regulations, a can labeled mixed nuts must contain at least 4 types of shelled nuts other than peanuts. The mass of each type of nut must not be less than 2% of the total mass and not more than 80% of the total mass. Oh, that's a fun fact. How are the 2 brands of mixed nuts alike, and how are they different? So if we look at this, we have brand A and brand B, and it's a mixture of their mixed nuts, right? So brand A has less peanuts than brand B. Brand A has more almonds than brand B. Brand A has way more Brazilian nuts than brand B. Brand A has less cashews than brand B. Brand A has more hazelnut than brand B. And brand A has more pecans than brand B. Okay. Both brands contain the same type of nuts, but the amount of each type differs. So brand A's proportions are going to be like this, or brand B's proportions are going to be like this. So calculating the percentage by mass of each type of nut can be like this. So if I broke it down compared to the whole, 44.2% are peanuts. We're going to talk about brand A right now. That's what we're talking about. 13.64 are almonds. 16.79 are Brazilian nuts. 13.4 is cashew nuts. 5.7 is hazelnuts. And then 6.2% is the pecans. And as you look at the percentages for brand B, I'm not going to read them to you, but clearly they're different percentages. Are they all mixed nuts? Yes. Are they the same proportions? No. Therefore, these are mixtures. If they were the exact same percentages, you might be able to argue that this is a pure substance. But it's not. It's just a plain old mixture. So drawing a conclusion, do the contents meet the FDA regulations? Yes. They both contain at least 4 types of nuts other than peanuts, and the masses are within 2 to 80% of the range. On brand A label, the nuts are listed in order: peanuts, Brazilian nuts, almonds, cashews. What do you think determines the order? The ingredients are listed in order by total mass. The ingredient with the largest amount was first. So what is the main difference among solutions, suspensions, and colloids? Well, the size of the particles in the mixture has an effect on the properties of the mixture. Based on the size of the largest particles, a mixture can be classified as a solution, a suspension, or colloid. Solutions. Solutions, when a substance dissolves and form a homogeneous mixture, the mixture that forms is called a solution. If I take a little bit of salt, pour it in water, stir it up, the salt dissolves completely, it looks like water. Okay. Suspension. Suspension is a heterogeneous mixture that separates into layers over time. Oil and water. If I take oil and I pour it in water, and I mix it up in a blender, I'll get a liquid, but over time they will separate. A colloid contains some particles that are medium in size, between small particles in the solution and larger particles in the solution in a suspension. Like solution, colloids don't separate into separate layers. You cannot use a filter to separate the parts of a colloid. These liquids represent three categories of mixture. Windshield wiper fluid is a solution. They put coloring in it to give it that color, but it's a cleaning solvent in water, mostly water. Muddy water collected from a swamp is a suspension. Over time, the dirt will settle to the bottom and you'll have water left on top. Milk is a colloid. Milk will be milk no matter what. But what is milk? Milk is lactose, water, some other things, butter, fat. But it doesn't separate over time. It just remains milk. But it's a combination, a mixture of things. So real quick, help me answer these questions and we'll call it good on this section. Which of these substances are a compound? You can blurt it out. What do you think it is? Water. A compound is a combination of two things. Copper is an element. Oxygen is an element. Carbon is an element. Water is 2 hydrogen per oxygen. Always. Which of these groups of letters could be used as a symbol for an element? Remember, the first letter is capital. The second letter is lowercase. Which one? Well, it can't be A because they're both capital letters. Could be B, capital C, lowercase m. Can't be C because it's 3 letters. D is not the proper way to do it. That's actually, if that had a capital F, it would be iron, but it doesn't. So B is the correct answer in this case. Which of the following statements does not apply to a compound? It is made of 2 or more elements. No, that's true, it is. It has components that are joined in fixed positions, or proportions, not positions, proportions. That's true because water is 2 hydrogen atoms per every oxygen atom. It can be separated into components by physical methods. Ooh, I don't know if we could do that with water. Can I take water and just physically remove the hydrogen from the oxygen? No, I need some sort of chemical process or something that breaks the bonds between the hydrogen and oxygen. It could be broken down into elements or other compounds. That's true. You can separate the oxygen from the hydrogen. You just can't physically do it. I can't take my hands or anything and separate them. I have to have some sort of process that breaks the bonds between the hydrogen and oxygen. If you take water, shock it with electricity, that's enough energy that goes into the system that breaks the bonds, and that separates the hydrogen from the oxygen. So I think it's C. Yep. All right, how does a compound differ from a mixture? A compound cannot be broken down into simpler substances. A compound can be separated by physical processes and mixtures cannot. Actually, I think that's the other way around. A composition of a mixture cannot vary. No, that's not true. It can vary. A compound is made of two or more elements in fixed positions. Ooh, that's a tough one. A compound cannot be broken down into simpler substances. Compound, let me reread these, can be separated by a physical process. No, composition of a mixture cannot vary. That's not true. I think it's D. Yep. Because that's just a true statement about a compound. So what they're saying is that a compound has a fixed proportion, 2 hydrogen per oxygen. A mixture can vary. If we go back to the mixed nuts, you can have all kinds of proportions. It can vary, okay? Which of these materials is heterogeneous? Heterogeneous. Oh, I know the answer. What do you guys think it is? It's going to surprise you. We said it? Yeah, I heard somebody kind of whisper it. C. Sand is crumbled up rocks, crumbled up minerals, crumbled up stuff, and it's a mixture. If you ever pick up sand and you look at it real close, there's light brown stuff, there's white things, there's gray things, little black things. Those are tiny, tiny ground up rocks and minerals and all kinds of stuff. Which of the following can be separated with a filter? Colloids, compounds, solutions, or suspensions? What do you think? Think it's D? Okay, you're right. If you thought it was D, you were right. And that's it. That's all she wrote. Good job.